Okay, so today we are solving two interesting problems based on class 12 JEE Main and JEE Advanced exam and also WBJEE exam also. Okay, also students who are preparing for CSIR-NET get JEST, they may also face such problems in their exams. So let's start to solve it. So we are asked to solve this problem. They are giving us a circuit. Okay, and we are asked when VA minus VB is equal to 0, they are giving us 4 options. Okay, we have to find out the correct option when VA minus VB is equal to 0. Okay, as my space is limited, so I can remove this option. Okay, otherwise I have not sufficient space. Okay, so the options will be in this way. Okay, so what is VA? We know that C is equal to Q by V. Okay, so V is equal to Q by C. So VA is, so once C is equal to Q by V, V is equal to Q by C. So VA is Q by C1 and VB is Q prime by C3. Okay, so we have to find out when VA equal to VB. Okay, here we can apply Kirchhoff's second law. So in this loop, if I take it a P, it is A, this is Q, okay, and this is R, this is S. So this is a closed loop. This P, A, Q, R, S, A, R, S, P, sorry, P, A, Q, R, S, P. This is one closed loop. Okay, so in this closed loop, P, Q, R, S, P. Okay, in this closed loop we can apply Kirchhoff's second law. Okay, so this is, okay, 1 second. So this is plus, this is minus. Similarly, this is plus charge, this is minus. Okay, so from this loop, using Kirchhoff's second law, Q by C1 plus, this is Q by C2. Okay, as plus sign is present, so plus Q by C2, and here before this EMF there is present a negative sign, so this is minus E. Okay, this is 0. Okay, from here, okay, they are giving also these options also. So for as I have not enough space, okay, so I can remove this option basically. Okay, so you can solve this Q from here. So what is Q? Q is equal to E. Okay, this is C1 C2 by C1 plus C2. Okay, similarly in this loop, this is M. Okay, this is M, B, Q, R, S, M. So from this closed loop, what is the closed loop? M, B, Q. I think this is not Q. M, B, then R. Okay, not Q. Sorry. This is M, this is B, this is R, this is S, this is M. Okay, in this closed loop, M, B, R, S, M. This is M, B, this is again, this is S, this is M. This closed loop. In this closed loop, this is plus charge, this is minus, this is plus, this is minus. We can apply again Kirchhoff's second law. So this is Q prime by C3. This is Q prime by C3 plus Q prime by C4 minus E equal to 0. So what is Q prime? Basically Q prime is E into C3 into C4 by C3 plus C4. Okay, so we have to find out when VA minus VB is equal to 0 or when VA is equal to VB. Okay, So VA is equal to VB means Q by C1 is equal to Q prime by C3. Okay, so VA equal to VB. So this is Q by C1 equal to Q prime by C3. Okay, so Q by C1 is equal to E C2 by C1 plus C2. Okay, E C2 by C1 plus C2. Again, VB means Q prime by C3. I think VB is equal to, what is VB? VB is equal to Q prime by C3. From this equation, Q prime by C3 is equal to E into C4 by C3 plus C4. So from this equation, what we find, C2 into C3 plus C2 into C4 equal to C1 C4 plus C2 C4. Okay, so we can cancel out C2 C4. So from this equation we can write C2 equal to C3 is equal to C1 C4. So C1 by C2 equal to C3 by C4. So this is the correct option. Okay, C1 by C2 is equal to C3 by C4. So we have to find out the condition when VA minus VB equal to 0. So we can use Kirchhoff's second law. From this Kirchhoff's second law we can find out the exact option. So, okay, second another interesting question. They are giving a circuit. We are asked potential difference between two plates of each capacitor. Okay, potential difference between two plates of each capacitor. So potential difference between two plates of this capacitor is, what is, I think I can write it as V1 is equal to Q1 by C. Okay, and V2 is equal to Q by C2. Okay, so again in this circuit we can also use Kirchhoff law. Honestly, so we may feel hesitant. Okay, when we first look at this type of problems, we may look hesitant. We may feel hesitant. Okay, when we look this type of problem basically, but this is not so much difficult. We can use Kirchhoff's second law, and using Kirchhoff's second law, we can solve this problem. Okay, so again in this closed loop, this is a closed circuit. Okay, in this closed loop we can apply Kirchhoff's second law. So this is minus sign is minus, and this is plus charge. Again this is minus, this is plus. So in this second loop, second Kirchhoff's second law we can apply in this second problem. Okay, minus Q by C2. Okay, minus Q by C2. Why minus? Because minus sign is present here in front of this capacitor. Okay, again here is minus sign is present, so minus Q1 by C1, potential difference between these two plates of this capacitor, and here it is minus, it is plus, and here it is minus, it is plus. If I go clockwise, this sign, minus sign is comes, again this minus sign is come, minus sign is coming, and again this minus sign is coming, and here only here if we go in clockwise, so this plus sign is present. Okay, so here is minus E1 and here is plus E2. So from this equation we can solve Q C1 by C2 into C1 C2 equal to E2 minus E1. Okay, so Q is equal to E2 minus E1 by C1 plus C2 and C1 into C2. Okay, we are asked to find out potential difference between two plates of each capacitor. Potential difference between two plates of this capacitor is Q by C1. Potential difference between two plates of this capacitor is Q by C2. From this, so V1 we can write down Q by C1 equal to E2 minus C1. Okay, I am writing completely E2 minus C1 by C1 plus C2 into C2. And what is V2? Potential difference between two plates of second capacitor. This is Q by C2. This is E2 minus E1 by C1 plus C2 into C1. So we are asked to solve this problem, and we can solve these two problems easily using Kirchhoff's second law. Okay, this is a sign convention. Basically, I prefer this type of sign convention to solve this problem. Okay, so we may feel hesitant basically when you look first at the problem. Okay, this and this, but these problems are not difficult. We can easily solve it by Kirchhoff's second law. Okay, so bye.